Now, some of the applications of integrations, we start off with centroids. Centroids basically defined as the center of area given by x bar, y bar, where x bar is defined by the integral from a to b of xy dx over integral from a to b of y dx, and y bar is defined by this. So in order for you to get x bar, y bar, you need to remember these formulas here. Now here we are being told, find the position of the centroid. So we need to get the values of x bar, y bar, of the area bounded by the curve. So this is our curve, y is equal to 3x squared. The x-axis is basically y is equal to 0. And the ordinates, x is equal to 0 and x is equal to 2. Sawa sawa. So how do we go about this? We come to the solution. We first of all want to get our x bar. So solution. Our x bar is given by, follow the formula, integral from a to b. And what is our a to b? We've been given the x ordinates from 0 to 2. Clearly, as you can see, we're integrating with respect to x. So we have 0 to 2 of x. What's the value of y? Look at y. Y is 3x squared. 3x squared dx. All this is divided by what? Integral from a to b. So that is integral from 0 to 2. Integral from 0 to 2 of y dx. And what is our y? 3x squared dx. This is what will give us our x bar. So we can go ahead and evaluate this. So this will be the integral from 0 to 2, 3x squared multiplied by x, that is 3x cubed dx. All this divided by integral from 0 to 2 of 3x squared dx. Integrating the numerator and then the denominator. So if we integrate this, we will get the integral of this will be 3x raised to power 4 over 4. All this divided by, if we integrate 3x squared, that will be 3x cubed over 3. And we are evaluating integral from 0 to 2. Here also integral from 0 to 2. So if we finish off replacing 2 and 0, what are we going to get? So on the numerator, we will have 3 into 2 raised to power 4. All this divided by 4 minus 3 into 0 raised to power 4. All this divided by 4 over on the denominator. So this and this can cancel out. So I have x cubed. So that is 2 raised to power 3 minus 0 raised to power 3. And if we evaluate that, what do we get? So 2 raised to power 4. So this will basically give us, let's see, 16, 4, 12. So that will be 12. All this divided by 2 cubed, which is 8. And this will give us 1.5. And this is the value for our x bar. Now we go on and evaluate the value for our y bar. So what is our y bar? So our y bar will be given by the formula, a half integral from 0 to 2, that is a to b of y squared. But what is y? Y is 3x squared. So y squared will be 3x squared dx. All this divided by integral from a to b. So that is integral from 0 to 2 of y dx. And our y is 3x squared dx. So evaluating that, what do we get? So on top here, we have a half into integral from 0 to 2 of 9x raised to power 4 dx. All this divided by integral from 0 to 2 of 3x squared dx. Okay, here we have a half integrating 9x raised to power 4. That will give 9x raised to power 5 over 5. And the range is from 0 to 2. All this divided by integrating this lower side, we have 3x cubed over 3. And the range is from 0 to 2. So this can cancel with this. Replacing the values, I have a half into 9 over 5, 2 raised to power 5. 2 raised to power 5 minus, replacing with 0, I have a half 9, 0 raised to power 5 over 5. So this will obviously be 0. All this divided by 2 cubed minus 0 cubed. And what will that give? If we evaluate this, then we will get 32, 9, so a half. This will give us, so if you evaluate this correctly, we should be able to get 32 over 5, 9 over 2. So this will basically give us 18 over 5, which is the same as 18 over 5, which is the same as 3.6. So what's our answer? Our answer is X bar, Y bar. Our X bar we got to be 1.5 and our Y bar is 3.6. So we have 1.5, 3.6 as our centroid. That's how we get the centroid. Let's take up another example of how to evaluate the centroid. So example number 2, let's say you're told determine the coordinates of the centroid for the area lying between the curves. Y is equal to 5x minus x squared and the x-axis. So guys, from the formula of the centroid, clearly we need the range AB, and you can see we've not been given the range here. So the best thing is to have a rough sketch so that we can know the values of X that are bounding the area. So the area is bounded by this and this. So if we have a rough sketch of what that is, so if we are to make a rough sketch of that, we will have values of our random values of X with values of Y, where Y is 5x minus x squared. So for the value of X as 0, 0, 0, Y will be 0. For the value of X as 1, for the value of X as 1, we'll have 1, 1 here. X will be 4. For the value of X as 2, let's say, for the value of X as 2, so 10 minus 4, that will be 6. For the value of X as 4, that will be 20. 20 minus 8, that will be 12. So that's it. This is how this curve is going to look like. We can take, let's say we take another value for the value of X as 5, 5, 25, and then 5, 25. So X will be 0. So it's like at 5, it's at 0. At this point, it's at 0 as well. Now, what's the point of intersection for these two curves? Now, to get the point of intersection, we compare the two curves, we equate them. So the curve is Y is equal to 5x minus x squared, and the other one is x-axis, which is Y is equal to 0. So I have 5x minus x squared is equal to 0. This is equal to this. So this basically gives us x into 5 minus x is equal to 0. So we have a point of intersection at x is equal to 0 and 5 minus x is equal to 0, which basically gives us x is equal to 5. So at those 2 points, that's where they intersect. Okay, fine. So if we already know that those are our points of intersection, we can have a rough sketch of how the graph looks like. So if we are having this as our y-axis, we've said they're meeting at 0, 0, and also at this point. And these curves at 1, it's at 4, at 1, it's at 4, at 2, it's at 6, so it goes this way. And then at 5, we've seen that it's coming back to 0, so it's somehow like this. This is our curve here. So clearly we can see the point of intersection. We have 0 here and we have 5. Now, if we come to evaluate for x bar, y bar, so what's the formula for x bar? So x bar is given by the integral from a to b, which is now integral from 0 to 5 of xy dx. So x, what is the value of our y? Our y is 5x minus x squared, which is the curve. All this divided by the integral from a to b, which is the integral from 0 to 5. So the integral from 0 to 5 of y dx, and our y is 5x minus x squared dx. So what does this give? This will give us integral from 0 to 5 of 5x squared minus x cubed dx. All this divided by integral from 0 to 5 of 5x minus x squared dx. Integrating on top here, we have 5x cubed over 3 minus x raised to power 4 over 4. Range is from 0 to 5. All this divided by integrating down here, we have 5x raised to power 2 over 2, x raised to power 3 over 3. Integral is from 0 to 5. So if we evaluate that, we'll get on top. So we'll have this. If we evaluate that on top, we are going to get, this is 625 over 3 minus, this is 625 again, because it's 5 raised to power 4, all this divided by 4. So basically on top, we're going to have 625 and this over 12. If we put under the same LCM over 12. Okay, and then on the denominator, this is 5 raised to power 2, 25 times 2, 125 over 3. So we'll have divide by 125 over 6. So if we evaluate this correctly, we should be able to get this as 2.5, which is our x bar. In a similar manner, using the formula for y bar, we get the value for y bar. Now y bar is given by a half integral from 0 to 5 of y squared, and our y squared is 5x minus x squared squared dx. All this divided by integral from 0 to 5 of y dx, and our y is 5x minus x squared dx. So evaluating this, 5x minus x squared will give us, so I have a half here, 0 to 5. If we square this, we'll have 25x squared minus 10x cubed plus x raised to power 4 dx. All this divided by integral from 0 to 5 of 5x minus x squared dx. Okay, fine. Let's integrate the numerator, then integrate the denominator. So we have a half into, integrating the numerator, we'll have 25x cubed over 3 minus 10x raised to power 4 over 4 plus x raised to power 5 over 5. And the range is from 0 to 5. All this divided by integrating the values in the denominator, we'll have integrating the values in the denominator. So here you have 5x, so that will be 5x raised to power 2 over 2 minus x squared, integrating, that is x cubed over 3, ranges from 0 to 5. And replacing these values correctly, we should be able to get the value of our y bar as 2.5. So what's the centroid? Centroid is given by x bar, y bar, which basically will be 2.5, 2.5. And this is our answer for the centroid.